Hello. On next 3 nails we will solve some simple but quite useful and often task. We will try to use all that previous explained theoretical tricks and tips I explained in previous nails. So let's go to the task description. Look at the screen. We have global constant, max balance and max lag. They will be used in our core function which we will create. And also we have so-called helper functions. By customer ID we can go to the database, it simulates hard query to database, and extract the maximum customer lag due to first unpaid order, due to first unpaid sale. Yeah, how long we wait for the customer payment. And the second helper function, get customer balance, it also returns the debt, the customer debt, based on customer ID. And it's also emulation, but in real life, in real world, it relies on a hard DB query. And the simple check function we will implement is order allowed or not, and it should return boolean value true or false, and based on all that logic. And the final goal is to find out can we allow this customer order something or not. The input argument is a map of customer's data, customer's ID, name, and blocked key, and order amount. And the logic is quite simple. We can rely on our previously explained cond_let macro. It's shown here how it looks like, and here we can use it quite a lot. So first we check blocked parameter, and if customer itself blocked, we immediately return sorry plus name, you are blocked, and we do not need any queries to the DB, analyze customer balance, customer lag, and so on, compare it to the maximum possible values, and so on and so forth. Then we create a let block, we go to the DB, calculate the customer lag, and calculate the delta lag, how current lag is over on maximum lag value, and if delta is positive, we return sorry, your payment lag exceeded by and delta lag value. Then if lag check was passed, we go to the balance query and do the same things. We get the current customer balance, and then analyze can we allow customer order some amount due to maximum possible balance and his current balance. And if all the checks are fine, we return okay, you may have an order, and so on and so forth. So first of all, I'll show you how it macros cond_let expands, in which form. Yeah, and here in the REPL you see the regular combination nested if blocks and let blocks. It combines if blocked, return sorry, blah blah blah, then let block, let lag, let delta lag, and nested if, and so on and so forth. So as usual, as we described it before. And how it works, let me comment it. It works also very predictable way. If customer is blocked, sorry Andrew, you are blocked. If we trying to order a big amount of sorry Andrew, your balance is exceeded by 50, but if we trying to order some little amount, yeah, okay Andrew, you may have an order, your rest of lag is 5 and balance is 30. So here we rely on previously binded lag and balance and deltas values. And that's fine, it's a regular case, and it works fine, and we have nothing to predict and nothing which can happen. But let's imagine that by some reason, I don't know why, but let's don't take care about of it. But let's imagine that we will live without LED block. We can emulate it this way. So redefine LED but by some value, so we hide our closure core LED block. And that's why I actually call this namespace LED off. If you know, there was a big genius Russian poet and songwriter Igor Letov, and it was my reminder for him. Yep, so let's see how it will work without LED. First of all, we try to load the namespace itself, and yeah, unable to resolve symbol A in this context, and if we go below, we'll see that conlet macro use LED block here, because it expands nested forms in a LED blocks. And also, it's a trick that it uses LED block for construction macro itself. So we use LED twice in this conlet macro. First we make internal bindings of conlet macro, and then in recursive calls we use LED as a returned expanded value. But we can do the trick, as we know from the previous nails. We may create our own macro LED. It's actually a macros that it emulates the behavior of a regular LED block. Macro LED, it wraps all the nested forms inside a calls of inlined lambdas and so on. And when we will alter the conlet macro, we also use macro LED as here for internal conlet purposes, yes, as there for expanding in a outed form. So let's say file, load the namespace, and then the function will be the same, but let me show how it will macro expands. Let's say in REPL. It expanded in also the same nested if blocks, but in places of previous LED special forms. Now you see the inlined lambdas with some formal argument names, and the actual values of their argument names are shown there. So that's the real case of living without LED. So-called, we can live without LED, and it's nothing special, nothing critical, and everything's fine. Yeah, and if we will calculate this function, let me go back, comment macro expansion, and then evaluate it and do the calls. Yep, the results are the same. So the usage of conlet macro here, it almost the same without any differences, and it's independent. Do we have LED itself as a special form in the core of our language or not? So that's the way how we can live without LED if we have so powerful macro called macro LED. And in the next nails, I can announce you, we can try to implement all these things and solve all these tasks without macroses itself at all, without any macro expansion stage, without macro system of closure. So we will emulate the macroses where all the other rest of the things closure have. So see you on next nails.